Class 12 students, very good afternoon. As you can see on the board, I am here to revise chapter Coulomb's law with you. Remember that this is going to be a revision, a short revision video, so that it is helpful for your examinations. You can revise or you can go through the video at the last moment, just before your examinations, and get your concepts sort of revised, right? So let us talk about Coulomb's law. Now Coulomb's law is your first topic, a subtopic in unit, electrostatics. So when we are talking about electrostatics, we are talking about electrical charges. Electrostatics being composed of two words, na? It is made up of electrons and statics. The electro or electrons means we are referring to electrons, that is charges. Statics means we are referring to, or we are assuming that the charges are practically at rest. They are not, but in this particular unit, we are assuming that the charges are at rest. So whenever a charge is at rest or an electrical charge is at rest, whatever properties it will be executing or showing, those particular properties we are going to study in this particular unit. So there are so many properties, a charge, after we classify it into two categories, positive and negative, the charge may be attracting or repelling each other, as you know. The charge will be producing electric field around itself. Due to the presence of charge, a body will develop electric potential and so on. So there are a number of properties of charges that are to be studied. But uske pehle we should first of all know how the charges attract or with what magnitude they are attracting each other or repelling each other, and in what direction. So that particular concept is dealt under the heading Coulomb's law. We'll be talking about Coulomb's law later on. In this particular video, I'll be talking about charge and its important properties. So सबसे पहले, what is charge? See, charge is actually a fundamental or basic property of matter. So we are going to define charge in terms of the effect that the charge will show when it is present upon matter. So charge, if present upon a matter, charge is a physical quantity, you can say, or it's a property of matter, due to which two material particles will either repel or attract each other, right? Two material particles will either repel or attract each other. Now if I am talking about different properties of charge, the properties in short that we have to go through are the types of charge, two, we are going to come across the attractive or the repulsive behavior, that is behavior of charges with respect to each other. Then their additive nature. इसी में we are going to take up with the scalar nature also, the scalar and additive nature of charges. Charges being invariant, charges being conserved, or the conservation property of charge, charge being quantized, जिसको we call it as quantization principle of charge, and charges being transferable. So there are a number of properties that we have to go through. Maybe I have missed out with one or two, but we'll be covering it in the upcoming lecture. Not all properties can be studied simultaneously. Rather, we'll be concentrating initially upon very basic ones. In this particular video, I'll be trying to cover very basic properties. Some of them do have numerical applications also at your level. So let us start. सबसे पहले, if I talk about the properties, so I'll be talking about the types of charges that we have. So everybody knows that we have two types of charges, and those types are positive and negative. Types are two, respectively positive and negative. If I am talking about a positive charge, It means I am referring to a body which is deficient of electrons. Means if the body is having deficit of electrons with respect to its natural configuration, जो body का natural configuration है, अगर हम उससे electrons ले लें तो उसमें electrons कम हो जाएंगे, and then we say that the body has acquired positive charge. So the deficiency of electrons will generate a positive charge on the body, and similarly if the body gains the electrons, that will generate excess of electrons, and the body will then acquire what? Negative charge. So any object having negative charge, we know that it is having excess of electrons, and any object having deficiency of electrons is having actually positive charge. So the charges may be classified into two categories. Remember that we can never say that a positive charged body is having excess of protons, because protons, they do not take place, or they do not actually take part in the transfer of charges. When the charges are transferred from one body to the another, that is basically in terms of electrons only. So when we are defining the positive and negative charge, we should be defining it with respect to electrons only. Protons का इस्तेमाल नहीं करना है, ध्यान रखिएगा इसको define करते समय. Then the units of charge will be concentrating upon two units, SI unit, Coulomb, capital C symbol, and the CGS unit being, याद है, ESU of charge, or we call it as start Coulomb, written as start C. The two units are mathematically related to each other as 1 Coulomb is equal to 3 into 10 to the power 9 start Coulombs. So 1 Coulomb is how much? 3 into 10 to the power 9 start Coulombs. Speed of light को 10 से multiply कर दो, you'll get this value. Moving on to another property, that is the attractive and the repulsive behavior between two charges. So let us talk about the behavior of two charges. बच्चों अगर behavior की बात करें, so similar charges repel, similar will repel, means positive and positive, or negative and negative, and dissimilar will attract, dissimilar. So as a thumb rule, we know dissimilar charges will attract, means positive and negative will attract, while similar charges will repel. So this is the general behavior of charges that we already know, ये आप जानते हैं. यहाँ पर important ये है जानना that if we want to confirm whether a body is electrically charged or not, then we have to use the electrostatic repulsive property of charges, not the attractive property. Remember that electrostatic repulsion, this is an important one. Electrostatic repulsion is the sure test for electrification. If you want to know why, the answer is attraction may take place even due to induction. Say we are having a positively charged body and we bring some other body which is actually uncharged. What will happen? The uncharged body will get polarized. It will develop poles, positive and negative. If we are having a positive body, then the negative pole will be developed. See, like this. Suppose we are having a positive charge present on a body. This is the charged body. Now we want to know whether another body that we are bringing near, that is say object B, we want to know whether this is charged or not. Actually we know this is uncharged, but if you test it here, what will happen? Due to induction, this end will be negatively charged while this end will be positively charged. Now the two ends, positive and negative, they will attract each other. So attraction is even taking place even if the body is actually uncharged. So electrostatic attraction is not the sure test for electrification. It is the repulsive property of charges that will give us the information whether the body is electrically charged or not. Right? Now moving on to another property. कहते हैं कि charges are invariant. What do we mean by that? What do we mean by invariancy of charge? See, any physical quantity is said to be invariant if its value remains constant. Any physical quantity will be said to be invariant if its value remains constant with respect to the speed of the object. So let us take an example of two physical quantities. Let us talk about mass and let us talk about charge. Say the initial charge on the body is Q and the initial mass of the body is say M. Now what happens? Initially the body is at rest. So if the body is at rest, this is known as rest mass and this is known as rest charge. Here the velocity of the body for both of them is 0. So we can also call this as rest mass and we can also call this as rest charge, or the value of charge when the body is at rest. Now what happens if you increase the speed of the body or the body starts moving? What will happen? तो अगर मटेरियल पार्टिकल चलना शुरू करता है, so the mass will change with speed as per the relation m dash equals to m upon under root 1 minus v square by c square. But the charge at a particular speed will remain constant. It remains as q. That is, q dash will remain as q, whatever is the speed of the body. Now the speed is non-zero, but you can see charge does not change with speed, but the mass changes with speed. So mass is said to be variant while the charge is said to be invariant. This is what we mean by invariancy of charge. अगर किसी बॉडी पर 10 कूलम ऑफ चार्ज है और उस बॉडी का 10 ग्राम मास है, अब ऑब्जेक्ट अगर हाई स्पीड पर चलना शुरू करता है तो मास विल स्टार्ट चेंजिंग, इट विल एक्चुअली स्टार्ट इंक्रीजिंग व्हेन द चार्ज विल रिमेन एज 10 कूलम्स, नो चेंजेस. अगर मास इंक्रीज कर रहा है कैसे पता करेंगे? देखिए, पुट v इक्वल टू 0 एंड सॉल्व दिस फॉर्मूला. सो 1 माइनस 0 इज 0, स्क्वायर रूट ऑफ 1 इज 1, दैट मीन्स m डैश इक्वल्स टू m. इसको कह रहे हैं आप रेस्ट मास. नाउ से लेट अस टेक एन एग्जांपल वेयर द स्पीड ऑफ द बॉडी इज इक्वल टू c. Put v equal to c in the above formula. If you do that, c square by c square will be 1. 1 minus 1 will be 0. Square root of 0, 0, and anything upon 0 is infinity. So m dash comes out as infinity. You can see the mass of the body is increasing from m to infinity with the increase in speed of the body. But the charge remains constant. So that is why we say mass is actually variant and charges are invariant. तो अगर एक लाइन में बोलें, what is meant by invariancy of charge? Simply, the value of the charge will not change with the speed of the body. The value of the charge present on the body will not change with the speed of the body. That is what is meant by invariancy of charge. Right? एक और property लेते हैं इसके बाद. क्या? The charges are scalar or additive. ना? The charges are scalar or additive. The charges are actually additive because they are scalar. ना? So when we are talking about additive nature of charge, that means being scalar, the charges will be summed up as total charge on any object equals to q1 plus q2 plus q3 and so on plus qn. q1 plus q2 plus q3 and so on plus qn. Remember that since you are performing sum or summation of a scalar quantity, so we have to use signs of q1, q2 and so on qn. You have to place all the charges with sign. For example, suppose there is an object which was initially having 10 coulombs of charge, right? Now what happens is you provide some more charge to it and say this time we are giving it minus 4 coulombs. So what is the total charge present on the body after 4 or negative 4 coulombs have been given? It will be like q equals to previously present 10 plus given minus 4. You have to use the sign. So that will give us positive charge of 6 coulombs present finally on the body. Right? So this is what is meant by additive nature of charge. Being scalar quantity, the charges can be simply added up by putting their respective signs. Fine? So I suppose we have discussed with nearly half of the properties of the charge. Still left with quantization of charge, conservation of charge, and how the charges are transferred from one body to the other. So class, now I'll be talking about the quantization of charge. What is meant by quantization of charge? See, a quantization charge principle can be simply put up as q equal to NE. That is by the formula itself. But first of all, let us understand what are the physical quantities that are quantized and what are the respective expressions. The quantities quantized are, number one naturally is charge, and the expression is given as Q equals to N into E. Mass seems to be quantized, so it is M equals to N into, I'll place the bracket here itself, N into something. This dash is empty actually, we don't know. This bracket is actually empty. So quantum of mass actually we don't know. Similarly, if I say angular momentum, so angular momentum is conserved, and the expression for the same is mvr, that is L, equals to N h upon 2 pi. And there's one more, that is the last one, energy, that is E equals to N h nu. So these are four physical quantities which are actually quantized: charge, mass, angular momentum and energy. You can see everywhere we are using N on the right hand side. N anywhere can have values from 1, 2, 3, 4 and so on till infinity. Means N cannot have fractional or decimal values. That is the actual meaning of quantization. When I say a particular quantity is quantized, that means we are having a quantum that is the smallest unit of that particular physical quantity. For example, anything that is written here in bracket along with N is actually the quantum of the physical quantity. For example, E here, that is charge of electron, is the quantum of charge. Mass we don't know what is the quantum. H upon 2 pi will be said to be the quantum of angular momentum. H nu will be said to be the quantum of energy, right? So this is what is actually meant by quantization principle of any physical quantity. Now you can also state it like, since I'm saying this is quantum, this is quantum, this is quantum and this quantum we don't know. So quantum is actually the smallest value. It cannot be further broken down to simpler terms. So the smallest value of charge that can be present on any body is the charge of the electron. Similarly, the smallest quantum or value for the angular momentum of any body will actually be the multiple of h upon 2 pi. So h upon 2 pi is the lowest value. It cannot be further divided into fractional or decimal. This is what is meant by quantization. More on this in the next video. In the next video, we are going to concentrate upon the quantization principle of charge. Then we are going to concentrate upon what sort of numericals can be given on this particular property, that is quantization of charge. We'll take up with conservation of charge, and we'll take up with the methods through which charge transfer can take place. See you by then. Thank you.